In this video, we're going to talk about Module 1, Topic 3, Lesson 4. So this is modeling behavior. So a 12-ounce can of soda was put into a freezer. The table shows the volume of the soda in the can measured at different temperatures. So part 1A says describe the data distribution. So we want to fill in the blank. As the temperature blank, the volume blank, and then blanks. So if we look at our table, notice that as we go down like this, our numbers are decreasing. So our temperature is decreasing, okay? When we look at our soda volume, notice that as we go down, we're decreasing. But once we reach this point right here, notice that it starts to go back to increasing. So when we fill in the blank, we're going to say, as the temperature decreases, the volume decreases, and then increases. Okay? Now, using the table, use technology to calculate the regression equation. Sketch the graph of the regression equation on the scatter plot. So what we're going to do is we're going to switch over to Desmos. So to do a regression on Desmos, you're going to hit this plus sign in the top left corner, and then you're going to select Table. And you're going to enter your data as it is on your paper. So go ahead and enter that as I enter it. Okay, so once all your data points are entered, double check to make sure you typed them in correctly. Now, over here off to the side, notice that you have this little magnifying glass. It says zoom fit. What that will do is it will automatically fit the graph to your data point. So I'm going to click that, and notice we can see our graph. Okay. What we need to pay attention to is what kind of shape these points are making. And notice it's making something that looks like a quadratic function. So we're going to run a quadratic regression. So now what we're going to do is we're going to click this. It has 4 dots with a line through it, and it says add regression. And right now it gave us a linear regression, and it graphed what the linear regression would be. Notice that it's not going through or close to many of our points. So we're going to hit this drop-down menu, and we're going to select quadratic regression. And notice now the quadratic regression goes through or is close to most of our points. So this equation down here is the equation of our quadratic regression, and that is what we need to write on our notes. So let's go ahead and write that on our notes. We're going to round to 3 decimal places, except on the first one, we're going to round to get at least 8. So we're going to write our equation. Okay, so now we're going to go through and we're going to talk about the data. Oh, before we do that, it did tell us to sketch a graph of the regression. So we're going to sketch a graph here. And it's going to look something like that, maybe. Okay, Now, we're going to talk about the data. What does the x and y values represent in this problem set? Well, in this problem set, the x represents the temperature of the can, and the y represents the soda volume. Now, the temperature of the can is measured in degrees Fahrenheit, and the soda volume is measured in centimeters cubed. Okay, now we're going to talk about the domain and range. So, as far as our graph goes, we're talking about this green graph, okay? We want to know what is the domain and the range of the graph, not related to the temperature of the can or the soda volume. So this is a quadratic function. A quadratic function's domain is all real numbers. Now we need to talk about the range. On this graph, we have a minimum. The minimum value is 354.88. Notice that all of the y values are either equal to 354.88 or they're greater than 354.88. Okay, so our range is going to be y is greater than or equal to 354.88. So, again, our domain is all real numbers. Our range is y is greater than or equal to 354.88. Okay, now on this next part, we want to state the domain and range of the problem situation. So we want to talk about the domain and range from our table, one that relates to the problem that we're working with. So if we're looking here, our domain is our x values, and we said x was the temperature of the can. So our smallest x value is 14. Our biggest x value is 68. So our domain is going to go from 14 is less than or equal to x is less than or equal to 68. Our range, we need to find the smallest y value and the biggest y value. So the smallest y value is 354.88. The biggest y value is 355.54. So our range is going to go from 354.88 less than or equal to y, less than or equal to 355.54. Okay, so now it says determine the y-intercept, the x-intercept, and interpret the meaning. So let's go ahead and write this down. Okay, so we're going to go back over to Desmos to find the y-intercept and x-intercept. So you may have to zoom out just a tiny bit so you can get the y-intercept. So if you click on the line, it shows you a gray dot, and that represents our y-intercept. So our y-intercept is 356.35. So let's go ahead and write that out. Now, we need to interpret the meaning of this. So, what does x represent? What does y represent? X represents the temperature. Y represents the volume. So, what this says in the context of this problem is at 0 degrees Fahrenheit, the temperature, or sorry, not the temperature, the volume of the soda can is 356.35. Okay, now, let's add in our units. So this would be centimeters cubed. Now we need to find the x-intercept. Now, with the x-intercept, we got to use a little bit of our critical thinking skills. Earlier, we said that the minimum value was 354.88. That is the lowest that it goes to, which means that it never goes low enough to cross that x-axis. So you could sit here and zoom out all you want, but notice that it's not even coming close to where that x-axis is. Okay, so that means we don't have an x-intercept. Now, if you zoomed out like I did and you want to fix it, again, you just hit this zoom fit, and it fits it right back to what it was. So there is no x-intercept. Now, what we need to know is, what does that mean in the context of this problem? In the context of this problem, what we need to understand is that x-intercepts are written as x comma 0. So what that's telling us is that our volume of our soda can will never be 0. There is no temperature that would make the volume of our can be 0. Okay, so the volume of the soda can will never be 0 centimeters cubed. Okay, again, there's no temperature that's going to cause that to happen. Now, on the last part for this question, it says predict the volume of the soda can when the temperature is 20 degrees Fahrenheit and 60 degrees Fahrenheit. So this is a prediction. When it's asking for a prediction, you're going to use the equation that you came up with. So we're going to go back to Desmos. There's a couple different ways you can go about this, and I think that the way that I'm going to show you is what I have found to be easiest. So what you're going to do is, next to the word equation, there's this little button that says export a snapshot to the expression list. So you're going to click that, boop, and notice it just copies and pastes your equation down. Okay, then once you do that, oops, let me zoom out some. I rearranged mine. Let me put it back so it looks like y'all's. There we go. Okay, once you have this equation right here, what you're going to do is you're going to hit this little gear button that says edit list. And then next to your equation, it has a table button, and we're going to create a table. And what this does is you can change these x values to get the y values that it's associated with. So we want to know when it's 20 degrees Fahrenheit, we type in 20, and it updates it to 355.26. We also want to know when it's 60 degrees, so I'm going to change that to a 60, and it updates it to 355.197, which rounds to 355.2. So that's how you can do that. And you can do that. So if you wanted to know when 55 degrees Fahrenheit, what's the volume? Boom. Okay? And so you could just keep typing in numbers if you needed numbers. So let me go back to the notes. At 20 degrees Fahrenheit, we said that it was 355.26, and that would be centimeters cubed. And for 60 degrees, we said that it was 355.20 centimeters cubed. You don't technically have to have the 0 there, but you can write it. It won't hurt. Okay, so there is that. Okay, looking at the next question. It says, Elsa decides to enroll in an introductory forensic science class. On the first day, Dr. Suarez tells Elsa's class that the crime scenes often involve speeding vehicles which leave skid marks on the road as evidence. Taking into account the road's surface, weather conditions, and the percent grade of the road and the vehicle type, they use the function f of s to determine the length in feet of the skid marks left by the vehicle based on its speed, s, in miles per hour. We want to start by completing a table based on f of s and label each column. So what we want to do is we want to find what are the output values when we have all of these numbers. Now, 25, 30, 45, 55, 60, 75, 90, 100, and 110, those look like they are speeds, okay? And so those look like there are input values. So if you notice in the equation, we have s's as our input values. And it tells us that s's are speeds in miles per hour. So we're going to label this column right here as speed of vehicle and it's going to be in miles per hour. And this is representing our s variable, which what we associate it with is x. Okay? Then that means the output is going to be f of x, or f of s. And f of s is used to determine the length in feet of the skid marks. So this is going to be the length of skid marks It's going to be measured in feet. This is f of s, which we know as y. Okay? So we were given an equation, so what we're going to do is we're going to go over to Desmos and we're going to type in this equation. But when I type it in, I am going to replace f of s with y and all of the s's with x's just to make it a little bit easier to type in. You can type it in with f of s and s. Again, it's just easier to use x and y. So when we go over to Desmos, we're going to hit the X to clear all of these out. And then we're going to type in our equation. So we have y equals 0.034 x squared plus 0.96 x minus 26.6. Okay, so notice when you graph this, you don't see a lot of the graph. So what you can do is you can come over here on the right side and you can hit the home button and it goes to the default viewpoint. And then from there, you can just pinch the screen and you can zoom out just a little bit and you can see the graph. Okay, so we see all of the graph here. Now, we want to fill in the table. To fill in the table, we're going to hit Edit List. We're going to create the table. And then we're going to type in the values we want. So we want 25, 30, 45, 55, 60, 75, 90, 100, and 110. So then you can fill these values in to your table. So we had 18.65, we had 32.8, 85.54, or sorry, 45, 129.05, 153.4, 236.65, 335.2, 409.4, and 490.4. Okay, so we filled in the table. So now, according to the table, what are the domain and the range? Okay, well remember domain is our x values. So in this case, our lowest x value is 25 miles per hour, and our highest x value is 110 miles per hour. Our range is our y values. So our range, the lowest value is 18.65. The biggest the biggest y value is 490.4. So now we want to know what is the domain and range of the inverse of f of s. Remember, to get the inverse of f of s, all we do is switch x and y. So if we're switching x and y, we're switching the domain and the range. So my domain for the inverse is my range of the original function. But when we write the domain, we have to make sure that we use x instead of y. And then for our range, it's going to be our domain of the original function, but we have to make sure we use y instead of x. Okay, so now on the next one, we want to graph the table values and sketch the graph of f of s on the grid shown. So to the best of your ability, plot these points and sketch it. So it looks something maybe like that. Then you can sketch a graph. Notice that it's only graphed in the first quadrant because it is a real world situation. You cannot have negative speed. You cannot have negative length of anything. Okay? Now, last two questions. Based on the model, what would the length of the skid marks be at 20 miles per hour and at 85 miles per hour? So this is where we're going to use that table. These are both x values or input values. So all we're going to do is add those to our table. So we can type in 20 here, and we can type in 85 here. And those would be our answers. So when it's going 25 miles per or 20 miles per hour, the length of the skid marks is 6.2 feet. And when it's 85 miles per hour, the length of the skid marks is 300.65 feet. So 6.2 feet and 300.65 feet. Okay, so that's the end of the notes. If you have any questions, make sure you write them down and ask in class. And don't forget to answer your essential questions in the summary.